Good morning, everyone, and welcome to today's webinar. We're going to be looking at the Fronius Wattpilot. So this is the EV charging solution from Fronius, which is now available in the UK and Ireland. Just to introduce myself, my name is David Porter. I'm one of the technical advisors here at Fronius, so supporting installers with training, design, commissioning, and after sales. And I'm joined today as well by Andrea Waller, who is our marketing and FSP coordinator. So the first thing to mention is Fronius have this vision of 24 hours of sun, which seems quite a strange thing to say. Obviously, we're only generating solar energy during the daytime, but Fronius plans to use energy storage and energy management to make sure that we're able to deploy that solar energy throughout the day, whether it's daytime or nighttime. Of course, there are many different aspects to this. Traditionally, we would be installing our solar system on the roof, connecting to our inverter, and obviously deploying that energy into the loads within the building or sending that back to the grid. Of course, many people are now installing energy batteries so that we can store the energy from the solar and deploy that on the site. We're also looking at using hot water through our own pilot solution, so heating a water tank or other resistive loads. And of course, now we're looking at charging electric vehicles using surplus energy where possible. So it'd be interesting to understand at the moment what you as installers, as solar system owners currently use. What sector coupling technologies are you currently selling or using yourselves? And we just have a very quick poll, which would be great if we could get your feedback for. So are you currently installing solar battery storage, such as the Gen 24 and BYD batteries? Are you using water diverters, such as the Ohm Pilot for heating hot water? Are you looking at energy management relays, so controlling individual circuits, switching heat pumps on and off, for example? Or are you already installing EV chargers? So it's great to see that everyone's already installing battery storage solutions. So that's brilliant to hear. And also the hot water is quite a common thing. Energy management relays, this is something that I think can be very useful for when you're controlling different loads which can be switched on and switched off. And we will be presenting more information on how to control those devices. And great to see you're already installing a lot of EV chargers. So hopefully what we present today may be beneficial to you and your future customers. So just going back to the sector coupling solutions, why would you want to install everything from Fronius? Why would you not want to pick and choose from different suppliers? Most importantly, it means that you can have a comprehensive energy management solution. We're using one single smart meter, and that has real benefits because it means that you only have one set of CTs, one monitoring device, and it means that you're able to seamlessly prioritize all the different devices on site. So it means if a customer prefers to heat their hot water, they can do that. If they prefer to charge the battery, that can become the main priority. And you're not going to have a situation where all the devices are fighting against each other for that available surplus energy. When you start to incorporate different devices from different manufacturers, you start to see one device taking control and always being the primary device, whether you want it to be or not. And of course, if everything's from Fronius, we can integrate that all into SolarWeb. So we can see the green energy for our battery charging, the red for our own pilot, purple for our own Wattpilot EV charger. And of course, we can see the states of charge and temperatures all in one place as well. So let's have a quick look at the basics of electromobility. What this means is the basics of charging a vehicle. And there are two main types of EV chargers available. We have our alternating current, our slow and fast chargers. So these are between 3.6 and 22 kilowatts of power charging your batteries. This is quite low cost these days. You're able to buy them from many different manufacturers and connect those easily into a residential or commercial infrastructure. You obviously will need more time to charge these because they are fairly slow, but it means that you're getting more energy directly from your solar and it can be used in many different installations. If you go to a rapid charger with DC, using DC current, you'll able to have much higher power charging. However, that means although you save a lot of time, it means that the infrastructure is much more expensive. It puts a lot more strain through the batteries. You're increasing the temperatures within the cells, and you're going to be reducing the lifespan of those products if you are using this on a very regular basis. It also means that you're going to have less energy coming from your PV because you're going to be working at higher power. You're going to be drawing more energy in from the grid. And as a result, the Wattpilot is an AC charging solution focusing on having the maximum energy produced by your solar and deployed into your vehicle. And whether you're using AC or DC, you have different charging cables as well. So with an AC connection, we use the Type 2 plug, which has 3 phase connections, neutral earth, and these 2 data connections as well. The key thing about the Type 2 plug is it's not an intelligent device. It doesn't provide communications between the car and the charger. It simply enables the charger to know what the current limit is of that cable in the car, and also the phase limitations as well, whether it's a single phase or a 3-phase device. The CCS plug, which you get on the high-powered DC chargers, that's a much more intelligent device. Obviously, it's capable of taking much higher currents, and it also has communications directly to the vehicle, so that if you ever look at the screen on a direct current DC charger, you'll see the state of charge of your vehicle displayed. That's not possible, unfortunately, with AC chargers. So what sort of vehicles can we charge? Well, there's maybe 3 main types of electrified vehicles. Of course, we have our self-charging hybrid cars. These have very small batteries with an internal combustion engine. And these do not have the ability to charge because the battery is so small. It is purely charged off the regenerative braking and the engine. You can maybe have a 400-mile range, and only 2 miles of that would be on pure electric. When we go into the plug-in hybrid vehicles, these have a slightly larger battery, but still also the internal combustion engine, and charging is optional. So it's not a requirement for you to get to the end of your journey, but it will reduce your fuel consumption during that journey. On these vehicles, you're only able to charge at 3.6 kilowatts. So at 16 amps per phase. This is really important to know when you're selecting your EV charger. Range again is pretty good, over 400 miles typically, and we can get maybe 25 to 40 miles on your electric range. So they're a good all-round solution. And then when we go to full electric vehicles, we'll have a much larger battery, maybe 50 to 80 kilowatts typically. Obviously, no internal combustion engine. They must be charged, obviously, and this is where we have those higher power chargers, the fast charging AC, and those rapid DC chargers, which may be well over 135, maybe 300 kilowatts now on some of the most recent vehicles. Typically, mileage of 300 miles is claimed, a range is claimed. However, in real world conditions, maybe 240 is more realistic. So which charging cables do we use? Which charging units? Well, obviously with the self-charging hybrid cars, no wall box is used. Plug-in hybrids, they will only ever charge at 3.6 kilowatts, 16 amps, and single phase. So that's important to know if you're going to be using a plug-in hybrid car. If you're going to use a full electric, well, they'll have the ability to charge at a higher rate on the AC. Normally, 7.2 kilowatts AC on the single phase, or 11 kilowatts on the 3-phase. There are very few cars around that will provide 22 kilowatt 3-phase charging. I think the Renault Zoe is about the only one I'm aware of on the market. So this is very important when you're deciding which model of EV charger do you need to install. So let's have a look at the Fronius Wattpilot variants that are available. The Wattpilot Home 2.0 is the unit that's currently on the market, and there are 2 versions. The 11J, which means maximum of 11 kilowatts power, 3-phase, and then the Wattpilot 22J, which is maximum 22 kilowatts power. They're both able to work in 3-phase or single-phase mode. The 11J has a maximum of 16 amps supply. The 22 has a maximum of 32. Both devices are IP65 rated. Now, a lot of people will look at this device and straight away see this top-mounted gland, and they go, really? That's IP65? Yes, it is, and that's because this is factory fitted. The Wattpilot is a sealed unit, and this has been tested under laboratory conditions and confirmed that it is IP65 rated, so no need to worry about water ingress with that. The connection is made to your local network, to your local grid on the opposite end, so we'd normally be connecting into an AC isolator from the other end of the cable. We have thousands of units of the Wattpilot already installed throughout Europe with no issues around the water ingress problem. So there's no concerns there with that top-mounted gland. So which model of Wattpilot do I need for my vehicle? It depends what type of vehicle you have and what the situation is, what your location is. If you're single phase, the PHEV, the plug-in vehicles, will work perfectly fine with the 11J, the 16 amp single phase charging option, because that's the maximum that that vehicle can charge at. If you have a full EV on single phase, you want to go to the 32 amp version, the 22J. And that's so that you can get twice the power from that. You can get up to 7.2 kilowatts of power to charge your vehicle. If you're on commercial installations, again, the 11J is absolutely fine for the plug-in hybrid because that's the most it can charge at. If you go for the full EV, then again, you only need the 11J. And the reason why is if you're working three-phase, got 3 times the 3.6 kilowatts, and that's the maximum that that car can charge. So it's only really if you're single phase with a full electric vehicle that you need to go for the home 22J variant. All the others situations will work fine with the 11J. If you do, however, go for the higher current device, it will automatically reduce the output depending on the vehicle. So you're not going to have a situation where you're going to damage the batteries of the car or the cables by using the higher current device. It will automatically lower to the correct current setting. So what's in the box? To start with, you have your mounting plate. So mounts flush to a wall, and then the Wattpilot snaps onto the front of that mounting plate. You have a fuse as well for replacement if necessary. Only use the ones that are provided by Fronius. We have a small metal bracket, which is used for managing the cable out of the top of the Wattpilot, and then a padlock can be used to make sure that it's secured and can't be removed. We then have our RFID reset card, and this has details for the Wi-Fi access point, so you can communicate directly with the device, and it also enables you to do a factory reset. We have our ID tag. The tag here, which you can put on your key fob, can be used for activating charging sessions. And then finally, we have our quick start guide for the installers on site. And of course, download the Solar Wattpilot app free of charge. That's used for commissioning, but it's also used for changing settings within the device once it's set up and running. There are also some optional accessories that you can buy. So we can have additional Type 2 cable. So if you want to turn this into a tethered wall box, so where you have a permanently connected cable, you can do that by installing the Type 2 cable and enabling the device lock within the settings. That means that you only need to have one device, but you can turn it into a tethered, locked Type 2 charger. We also have our cable hook for managing cables, and we can buy a box of up to 10 of the ID tags. So if you have members of staff within the property that you want to give access to, you can have up to 10 different users per Wattpilot. So let's have a quick look at the Wattpilot app. The main dashboard view of that shows you information on your current charging rate. So we can see whether you're charging from solar in yellow, green is battery, and grey is from the grid. So you can get a mix of different energy supplies. We can change the mode of charge, whether that's from the grid, whether that's using our eco modes, which we'll talk about later. And also we have the ability to change the current output as well. So you can manually increase and decrease the power of charging. And finally, we can set times for departure. So we can target when we want to have the device charging overnight, maybe. So we can do a lot in terms of visualization of the data and also controlling the device there. It's also necessary to use this app to commission the device on first installation. So how do we install the Wattpilot? Well, the great news is because it's a sealed unit, it's a very simple process. As I mentioned already, we've got that top entry gland, but it doesn't matter, it's IP65 rated. And what we would normally do is to connect out into a AC isolator, avoid having the device connected in direct sunlight. And that's because high irradiation can lead to high temperatures in the middle of the summer, which the device won't like. So try and put it in the shade, try and put it on a north-facing roof, or north-facing wall if possible. Connect into an AC isolator. If you're using it on a single-phase site, we'd recommend still using a three-phase isolator, but on the grid supply side, you're only going to be connecting to one of the phases. I would still put all three phases onto the load side of the isolator. That way the cables are all secured and everything's a nice, tidy, neat installation. You do need to install an earth rod or pen protection system if you're on a TNS network, so please bear that in mind. And then finally, once everything's wired in, you do need to use the app to commission the device. And we run through the commissioning app on the iOS app or the Android app by connecting to the Wi-Fi access point of the reset card. And then it's a simple step-by-step process. You choose the country of installation, you set the default charging times if you want them, you connect to the local site's Wi-Fi network, and then also if you have solar on the site, you choose an inverter to pair with so that you're able to control the charging rate. And we put a short commissioning video together, so hopefully this will clarify the commissioning process and you'll see how simple it is. In this video, we will show you how to set up the Fronius Wattpilot. First of all, download the Wattpilot app, go to the setup page, click on the QR scan button. This will open the camera on your phone and you'll be able to scan the QR code to enable the Wi-Fi connection to the Wattpilot. This may take a few seconds, but you should get a notification to say the connection was successful. Scroll down to the bottom of the page and make sure that you have connection, and then you'll be able to continue to the commissioning process. Firstly, choose the country of installation and press the next button. Now you can choose whether to accept the default off-peak charging periods. This is normally set from midnight to 8 AM. If you do not want to set this, click the reject button. Alternatively, you can customize preferred charging periods. Next, we must connect the Wattpilot to the same router as our Fronius inverter. Choose the correct Wi-Fi network from the list and then enter the password. After a few seconds, you should see a red tick next to the network to confirm you have a connection. Next, enter a password for the Wattpilot. This is so that you can connect the device from a mobile device in future. Now we must make sure that the correct inverter is connected to the Wattpilot. If the wrong inverter is connected, simply click the unpair button, and then from the available inverter list, choose the correct unit. Click the pair button to confirm the connection. And that is the completion of the setup process for your Wattpilot. You'll now be taken back to the main dashboard view where you can start your charging session. Scroll through the live data for your system and you'll be able to see the state of charge of your battery or the temperature of your hot water if you have either a Fronius battery or Wattpilot connected. You can easily set thresholds for both of these devices so that the Wattpilot will work in conjunction with them. So hopefully you agree, pretty straightforward process, step by step, to get that system commissioned. One of the things that's most important to consider though is the Wi-Fi signal strength. The device does need Wi-Fi to connect, so if you do have the router a long way away from the installation position for the Wattpilot, I would consider putting a Wi-Fi router nearer to the device. That's probably a key thing to consider for the reliability of the signal and communications. You also saw at the end of that video, we mentioned about the prioritization with the PV battery and the Wattpilot. You can set within the app battery thresholds and temperature thresholds. So if the state of charge of the battery is below the threshold, then the priority for surplus solar will be to charge the home battery. Likewise, if the temperature is below the set temperature on the Wattpilot, the energy will be diverted to heating before being made available for charging the vehicle. So we're able to set those priorities again. And then also in turn, if you want to make changes between the priorities of the battery, the hot water and the load management relays, you do that from the Gen 24 inverter or the data manager. However, as you can see, all these devices can be designed to set up different priorities at different times of day and based on different requirements from the end customer. So let's have a look at the various different charging modes that are available with Wattpilot. The simplest thing, of course, is easy charging, charging with a fixed preset current. So if you're going to be wanting to get the car charged as quickly as possible, you just crank this up to the maximum and charge away to get that car ready to go on your journey. However, if you have a grey, miserable day and you don't want to be using excessive grid energy, you can either press the button here or use the app to reduce the current and use a much slower, lower charge rate, which may save you money in the long term. You can see the charge rate based upon the LEDs illuminated around the outside of the connection. The more LEDs signify the higher the charging current. The next thing we can do is also use the off-peak scheduler. So we can, for example, charge the car during off-peak night rates, which again may save the end customer a lot of energy. This is ideal really if they don't have any solar energy and they just want to benefit from cheap overnight rates. You could also tell the device not to charge during peak tariff times. So for example, in the evening, 4 till 7, you could switch off the charger so that you're not buying in energy at an expensive rate. The next thing to consider is eco mode, and this is where we only use surplus energy from solar. So we're able to dynamically control the charging rate based upon the energy generated and how much is already being used within the building. And you can also see that we can convert between 3-phase and single phase to get down to much lower charging powers as well. And that is a fully automated process. One key thing to bear in mind in pure eco mode is that you will not get any charge if there is no surplus energy. So you can plug your car in on a grey, miserable day, and at the end of the day, have no more energy in that vehicle. So in that case, you're better off using our next trip mode. And this combines using the eco mode and the schedule mode. It means during the day, we can benefit from the surplus solar. We can tell a target amount of energy and a target finish time, and then whatever remaining energy needs to be filled in will be done overnight at that cheap rate. So you're getting the best of both worlds there. You're getting the surplus solar where you can, and then you're also getting the cheap energy to complete the charge and reaching the target required energy levels. So you can see you can set up some quite sophisticated rules if need be to get the best out of your PV system. The Wattpilot is also integrated into SolarWeb, so you can see the energy flow within your site And if you click on the bubble diagram, you'll then be able to see a breakdown of all your different consumers. And you can see on our site here, we have our own pilot, and we also have 3 Wattpilots installed. So we've got 3 EV chargers. If you click on the energy balance, you then see a breakdown of the energy flow, and you can see how the various different loads have been acting during the day. You can look at that over a month, year, and total view as well, and get a real idea of the savings that you're making with these different technologies. You can go into a lot of detail with the analysis as well. You can look at the voltages, the currents. You can even see the Wi-Fi signal strength here. This may be quite useful if a customer is having connection difficulties. You can see if potentially they would benefit from a Wi-Fi repeater. We can also see the Wattpilot in the SolarWeb app. And again, we see a breakdown of the different devices on site as well as the bubble diagram. So this is really useful for end customers just to see the data that's visible. They can also just remember if they want to make any changes, you do that from the Wattpilot app. So viewing data all in one place in SolarWeb. But if you're doing any changes to the system, changing the charging strategy, you do that in the Wattpilot app. Another more advanced feature is our load balancing. And this is really designed where you have multiple Wattpilots on the same installation. The key thing to consider is when you have a lot of EV chargers and other loads within the building, you have the potential of overloading your main incoming supply, particularly if there isn't any solar available. So the idea is that we can balance the available current between different vehicles. How do we do this? Well, what we have, for example, is a property here where we have a maximum grid supply of 32 amps. We've got some household loads switched on. I don't know, it could be an oven or something, tumble dryer. And we have 16 amps being used within the loads. That means we still have 16 amps available that we can use to charge up our vehicle. That's great, everything's going to work fine. But if then we charge a second vehicle, we have to balance the loads between the two. We've only got 16 amps of surplus energy capacity remaining, so that's now split evenly between the two devices. If we then have some solar generation, perhaps we've got another 8 amps being produced by the solar inverter to add to the 32 amps from the grid. We've now got a total of 40 amps that we can deploy within the property. We've got our 16 amp loads in the building. We can then put the remaining 24 amps between the two EV chargers, so dynamically adjusting the output there. What if the household loads increase? Somebody turns on another piece of equipment in the property. Well, then the Wattpilots will dynamically reduce their output to again avoid overloading that main grid supply. So the key thing with the dynamic load balancing is it's great where you have up to 3 devices all on one site and you don't want to be exceeding the incoming supply limit. Particularly, this focuses on commercial customers where they may have a set maximum import current from their energy supplier. And when they go over this limit, they'll get additional charges. So making sure that you're below that maximum grid supply limit will avoid additional penalty charges on your energy bills. Next thing to look at is the OCPP, which is the Open Charge Point Protocol. And this is standardized software which enables the Wattpilots to communicate with different charge point operators and e-mobility service providers. This means that billing and control within larger networks can be arranged. And key to that will be the Fronius email service, which is our energy management and EV charging solution, which will be available from next year. And that allows us to dynamically control the devices around a range of different sites. So for large installations, multiple Wattpilots, and also multiple sites situated all over the country or even the world. That can all be done from the Fronius email. And then a few more features just to consider. Obviously, we've already mentioned about the cable lock, so we can lock a cable into the device, turning it into a tethered solution. We can use a padlock for theft prevention. We also have a residual current device built into the device. So we have a 6 milliamp DC RCD, so there's no external Type B needed on this device. Every time you do a charging session, the device will do phase and voltage examinations to check that we're within the required limits, and we have that built-in temperature monitoring as well. So if we have any issues with the device, we go through the standard Fronius tech support process, either calling our tech support line or using the Fronius SOS tool. You'll also get a lot of information from the app locally as well. But we find there's very few issues with these devices. The key thing is, as I say, a strong Wi-Fi connection. And in summary, just to go through some of the things we've seen today, the Wattpilot can be used as a standalone and PV optimized EV charger. You can use it without any solar, but the real benefit comes when you have PV on the site. It can be easily commissioned via our solar Wattpilot app, so you can download that and explore that straight away. You can allow prioritization of various different loads. So that can be setting a hierarchy of control, whether the solar battery or the car or hot water takes priority of energy on site. You can have one smart meter to control all these devices. You're no longer having a box full of different CTs from different manufacturers controlling all your different devices. You have the integration and visibility in our SolarWeb platform for monitoring and diagnostics. You have the control, the security through the RFID tags so that you can allow certain people access to the devices. We have eco, next trip and schedule charging modes, so you can maximize the amount of surplus solar that's being used on site. We have the load balancing of multiple Wattpilots if you're going to have a larger installation. And also in future, we will have that email and the OCPP communications for remote energy management. So if you want to find out more about the Wattpilot, the Wattpilot datasheet is available in the handout section on the right-hand side of your screen. You should be able to just download that right away, and that'll give you the PDF version of the Wattpilot datasheet. So please take a copy of that. And if you want to see more information about Fronius products in general, I'd recommend looking at our Fronius E-Academy. And this is where we have modular trainings on all the various different products available from Fronius. At the end of that, there is certification to show that you've undertaken training, and you'll be able to then come to our Day 2 FSP course as well to undertake face-to-face training and to learn the more detailed features and functions with the Fronius products.